All right, so lesson 9.1 is the beginning of the new unit, and we're talking about surface area and volume in this unit. So in the last unit, we talked about two-dimensional figures, so flat figures like a square, a rectangle, a trapezoid. In this section, we're going to talk about three-dimensional figures, so like a cube or something that has a height, a length, and a width. So it's going to have three dimensions. So first of all, the three-dimensional shapes are called solids. So there's your word solids. When a solid is formed by polygons, then it is called a polyhedron. So now again, you have to think about your last chapter. If it's formed by a square, a rectangle, a trapezoid, a rhombus, or any of those that you learned about in the last section in Unit 8, if the solid is formed by those, then it is called a polyhedron. The plane surfaces of a polyhedron are called faces. So every part of the polyhedron is called a face. So like this square right here would be a face. But this pentagon here, it also is a face. So all of the little pieces that make up a three-dimensional figure are called faces. And the segments that join the vertices of the polygons are called edges. And that kind of makes sense. Let me see if I can get a different color here. So like this would be an edge right here, or this would be an edge. So it's really just exactly what you would expect it to be. And the two bases of a prism. So now here again is a new word, prism, right? So if it's a prism, it's going to have two congruent polygons that are parallel. So if you think about a box, which would be another way of calling it would be a rectangular prism, right? It would have a rectangle as the top, and it would have a, it would have a rectangle as the bottom. So those would be called, those here are the two bases, and then it's just joined. I didn't draw it very well, but you get the idea. And then it's joined by all those edges, and then there you get your prism. So this is a prism because the top and the bottom are congruent polygons. But then you also have this other word, which is a pyramid. Now, a pyramid is only going to have one base. So if you kind of think about the pyramids in Egypt, you kind of know what I mean, where this is a little harder to draw, but like, let's say this is my base. The pyramid would just have one point, so its edges would kind of come down like this. So the difference between a prism and a pyramid is that a pyramid comes to one point right there, whereas a prism does not. So let's take a look at some of these examples. It says, tell whether the solid is a polyhedron, and if so, what is the shape of the base? All right, and you're always going to name the polygon by the shape of its base. So like, for instance, in this one here, this would be called a rectangular polygon because the base is a rectangle. So here, if we have this here, this one here, well, it has a shape right here. This is its base, but that is not one of the polygons that we talked about last term. It has a curved surface, so that's not going to be one of our polygons. So this is not a polyhedron. But this one here, this here has a base that looks like this, which would be a pentagon, and has another base here, which is another pentagon. So this would be called a pentagonal prism. I think it's actually right there, pentagonal prism, because the top and the bottom are pentagons. Now, if you wrote pentagon prism, I'd be okay with that. All right, so take a look at these. Tell whether the solid is a polyhedron, and if so, describe it by naming the base. So if you take a look at this one here, the very first one here, again, this is curved, so this is not a polyhedron. But this one here, all of those faces are polygons, and the two parallel bases are hexagons, right? 1, 2, 3, 4, 5, 6. So if it has 6 sides, it's a hexagon. And this hexagon here, the one in front, this one here, is parallel to this one over here. So this would be called a hexagonal prism. Remember, the prism all the way around, all of these faces are going to be rectangles. Now this one here, this has a base here, this is a base, and this here is a base. But what shape are those bases? They're parallel to each other, but those are triangles. So this would be a triangular prism. And this one here, if you take a look at this base and the one down here, this base here, those are going to be trapezoids, because remember, this is what a trapezoid looks like, if you remember from last chapter. So this would be a trapezoidal prism. So go ahead and see if you can work through the exercises here in lesson 9.1. Go ahead and send me your answers and I'll take a look at it and we can discuss anything that you have a question on. Just looking through quickly to see. There's this thing here called Euler's formula. Euler's formula gives you a relationship between the faces, the vertices, and the edges of a polygon. It'll tell you that the number of faces plus the number of vertices is going to equal the number of edges plus 2. So here, if you take a look at this particular figure, let's find out how many faces it has. So it's got 1, 2, 3, 4. It's hard to count on here. Let's count the sides. 1, 2, 3, 4, 5, 6 plus the bottom, so that'll be 7 of your faces. And we want to know how many vertices it has. That's what we're solving for. It has, how many edges does it have? So you have to count up the edges. So it's going to have 6, 6, and then 6 more around the side. So it's going to have 12 edges plus 2. So then you can put it into this formula and you can solve for V, and you're going to find out that it's going to have 7 vertices, which makes sense. You can just count them. There's 6 on the bottom plus 1 on the top, so that would be 7. So you can use that rule to answer those. And then here is the work, practice A. So go ahead and see if you can do this work. And then I'll make a new video for 9.2.